Hello everyone, welcome back for another one of Mr. Weldon's amazing videos on sequences. We're going to be talking about applications of sequences today. So we first want to talk about whether or not we know a sequence is arithmetic or not. We also want to learn how to relate sequences to practical applications. So like where do we see these types of scenarios in the real world? And we also want to use sequences to make predictions about those practical applications because that's their primary use, right? If we're going to create an equation table and a graph, we typically want to be able to make a prediction about what's going to happen in the future as we progress through the sequence. All right, so let's talk first about whether or not something is arithmetic. So last week we talked about the definition of an arithmetic sequence being a sequence that adds or subtracts by the same number as you progress through the sequence. Okay, so when you look at a sequence, the first thing you're going to want to find is a number that you might think is the common difference. All right, so when I look at my first sequence here, if I were to go from term 1 to term 2, I'm going from 3 to 3. So I got to think, what would I add to go from 3 to 3? Well, that would be 0. Then you've got to verify that it stays the same for any two consecutive terms, right? So if I added 0 here, then did I add 0 here? And I did, right? 3 plus 0 is still 0, right? And if I keep on doing this, I'm always adding 0, which is why the number is staying the same the entire time. So this is a list of numbers, even though it's the same number every time, it is adding by 0. So it is arithmetic. It doesn't matter what number you add by, as long as it's the same number each time. All right, so let's check this one out. All right, so I'm going to do the same thing here. So this is 2, 6, 10, 14. So if I go from 2 to 6, I'm adding 4. If I go from 6 to 10, I'm still adding 4. 10 to 14, I'm still adding 4. And 14 to 18, I'm still adding 4. So based on what I can see in this sequence, it looks like I'm adding by 4 each time. So this is arithmetic. All right, let's check this one out. So I'm going to do the same thing. I'm going to go from 2 to 4. That would be plus 2. But if I go from 4 to 8, well, that's adding 4. So notice here I added 2. Here I added 4. If I keep going, if I go from 8 to 16, well, that's adding 8. So that is not adding the same number each time, right? So this one is not arithmetic. You might be thinking, well, Mr. Weldon, if I look at it this way, I'm multiplying by 2, and then 4 times 2 is 8, and 8 times 2 is 16. So I'm multiplying by the same number each time. But remember, the definition of something that is arithmetic is that it has to be adding or subtracting by the same number each time, not multiplying. Okay, so don't get confused when you see a situation. It might be multiplying by the same number, but multiplying is not what we're looking for. We're looking for adding or subtracting as the pattern. All right, so let's move on. Let's start to look at some applications. We're going to try and transition over to some applications, and these are going to be some goofy applications just to try and have fun here. All right, so we have Destiny. She was doing her homework, and her dog came over and bit a piece of the paper off, right? So she lost part of her sequence. The only thing she had left were these two numbers of her sequence, so it's 18 and 21, right? So if I'm looking at term 1 of Destiny's sequence, it is 18 and term 2 is 21. Now she knew before the dog bit the paper off that this was arithmetic. Okay, so she should be able to continue the sequence here. So if I look at this, right, going from 18 to 21, I would add 3. So to go to my next term here, I would have to add 3 again if it's going to be arithmetic, right? So 21 plus 3 is 24. Right? That would be me adding 3 again. And then I would add 3 again. So that would take me up to 27. Right? And then I would do it again, and I would get 30. Right? I'm just adding 3 each time. And that's what they wanted. They just wanted me to write out the next 3 terms. So there they are, 24, 27, and 30. And then I know that this sequence would continue on forever. All right, so now what they want me to do is to write the equation of this sequence. All right, so remember that our equation is always going to be in this form. Common difference times n plus 0 term. Okay. So the common difference, forgot to put the e there, but the common difference is what we are adding by each time here. So we're adding by 3. So the common difference in our equation is going to be a 3. So I got to do 3 times n. Right? That's going to start off my equation, and then they want me to add the 0 term on the end. Well, this was term 1. Okay, this is not the 0 term. So to get the 0 term, I have to go backwards in my sequence. I have to go backwards. So rather than adding 3, which was what was progressing me forward, I have to go backwards, which means I have to subtract 3. So if I do 18 minus 3, I would have a 15 here. Now this is not actually part of the sequence, okay? This is a hypothetical term that would come before the first term if it did exist, but it's not actually part of the sequence. The only reason we really need this term is so that we can complete our equation over here. So we're going to do 3n plus the 0 term, so we would say 3n plus 15. That's how we build our equation. Right? And now that we have an equation, the equation actually becomes one of the more powerful tools that allows us to make a prediction, right? So if we were to go and say, well, when would this sequence produce a 252, right? So which term number would give a term value of 252? Would it be the 20th term? Would it be the 30th term? It's hard to tell. All right, so that's where this equation comes in handy. So they are giving me a term value of 252. That is an output. So I can take this 252 and I can replace t of n, the entire thing, with that 252. So I'm going to say 252 equals 3n plus 15. And then to figure out the term number, this is what they want, right? They want the term number, or the input, which is the n value in our equation. So I'm going to draw a line, and I'm going to use my equation solving skills to get n by itself. So I'm going to subtract 15 from both sides. And if I do that, let's see, what is 252 minus 15? I'm going to have to grab my calculator for that one. And I got 237. And then over here, the 15s cancel, so all we have left is a 3n. And now to get n by itself, I would just divide both sides by 3. Okay, so those are gone. And then if I do 237 divided by 3, I'm going to have to use my calculator again here. I get 79. Okay, so what this is telling me is that the 79th term will have a term value of 252. So if I were to continue this sequence all the way to the 79th term, I would see a 252 in the sequence. All right. So that's probably the hardest part with dealing with these sequences, is keeping straight what a term number and a term value is. And you just have to remember, a term number is the input, right? So it's what we would put in for n, and the term value is the output. It's what we would get on the other side of the equal sign. All right. So let's go. Let's look at a real world application. All right. So I have a dear friend. His name is Mr. Camacho, and I've noticed that he started wearing a hat all the time. Like every time I see him now, he's always wearing a hat. So there's only one reason that you would start wearing a hat all the time, and that's because you have a bald spot. All right. So when you get older, your hair starts to thin out, you lose it, and you go bald. It's a fact of life. And so Mr. Camacho is probably trying to cover up that bald spot with his hat. Now, I have x-ray vision, so I look through his hat and I confirm my suspicions that he does in fact have a bald spot. All right. Now, when I first observed the bald spot, it was 3 centimeters in diameter. Okay. So the first time I observed it, so if I'm thinking about this word problem and I'm trying to translate it into a table or a graph, this is my first piece of data, right? So when I first observed it, it was 3 centimeters, right? So here's my first observation, and the bald spot was 3 centimeters in diameter. So I'm going to put that into my table just like that. Now, a week later, so this would be week 2, right? The second week that I looked at it, it was 5 centimeters in diameter. So I could put a 5 here for week 2. So I notice that his bald spot is growing, and it's concerning, right? How big will it get? Now, 2 weeks later, in the 4th week, I decide to look one more time, and it's a massive 9 centimeters in diameter. So I'm going to go over here to week 4, and I'm going to put that 9 into my table. All right, now with that information that I have, I want to complete my table. I want to make a graph, and then I'm going to build an equation. So if I'm looking at this thing, I notice to go from 3 to 5, all right, so if I'm going from 3 to 5, I have to add 2. So if this is going to be an arithmetic sequence, I would need to add 2 again to get to the next term. So 5 plus 2 gives me 7. 7 plus 2 gives me 9. 9 plus 2 gives me 11. 13, 15, 17, and 19. So all I'm doing is adding 2 each time. Okay? And now I can go and build a graph for this thing. So you'll notice down here in my graph, right, I've got my x and my y-axis. So remember, x represents the weeks, right, or n. And the y-axis over here is going to represent the diameter, or t of n, right? So the second row of our table here. All right, so remember in the 1st week, the bald spot was 3 centimeters. 2nd week, it was 5 centimeters, right? In the 3rd week, it was 7 centimeters. So I'm just going through and I'm plotting these points that were on my table before. And remember, for a sequence, we don't connect the dots here, right? So at 4, we're going to be at 9 centimeters. At 5, we'll be at 11. At 6, we'll be at 13. At 7, we'll be at 15. At 8, we'll be at 17. And then one more here. So at the 9th week, we'll be at 19. And there I can see the shape of my sequence. I can observe how Mr. Camacho's bald spot is growing, and it's growing in a linear pattern here. So it looks like it's making a line, but I cannot connect the dots here. All right. Now remember, our equation, right, because I want to build the equation, it's the last piece of the puzzle here, is common difference times n plus 0 term. You guys really need to remember that. Okay. So common difference, we figured that out right at the beginning when we noticed that it was growing by 2 centimeters each day. So the common difference is 2. That's what we're adding by, times n. And then my 0 term would be the hypothetical term that comes before 3. So rather than adding 2, I would subtract 2 from the first term, and it would take me back to 1 centimeter. So I would have 2n plus 1. So my equation is t of n equals 2n plus 1. There's my equation. Now, what kind of predictions would we make with this? Well, let's assume Mr. Camacho's head is a massive 61 centimeters in diameter. All right, he's got a big head. All right, how long is it going to take before he's completely bald? All right, so assuming that if the bald spot keeps growing and eventually equals the diameter of his head, he'll have no hair left. Okay, so what they're giving me here, they're giving me a diameter, 61 centimeters. And if I look at my table, I notice the diameters are down here. It's an output. Okay, so that means I can take that 61 and I can plug it in for t of n. Right? So t of n gets replaced with a 61. And I can say 61 equals 2n plus 1, just like I did in the previous problem. And now, to figure out how long it's going to take, that's what n represents, right? How long is n? So the 61 centimeters was t of n. So I need to solve for n. So I'm going to draw my line, and I'm going to use my equation solving skills here to get n by itself. So I'm going to subtract 1 from both sides. Those cancel. 61 minus 1 is 60. And then I'm going to divide both sides by 2, right? And whatever I do on one side, I've got to do on the other. Right? So the 2's cancel. 60 divided by 2 is 30. And we get n by itself. So how long is it going to be? Well, it says n equals 30. And remember, n was in weeks. So it's going to take 30 weeks for Mr. Camacho to go completely bald. All right? The next question they ask is, what will the diameter of the bald spot be after 20 weeks? Remember, 20 weeks, this is an n value, that's an input. So if I take my equation, and I'll write this out over here, right? So here's my equation, T of n equals 2n plus 1. They're giving me the n value, right? So I can take this 20 and I can plug it in for n, right? So I'm going to say T of 20 equals 2 times 20 plus 1, right? They want to know how big this bald spot's going to be in 20 weeks. Let's see, right? So if I do 2 times 20, I get 40 plus 1, and 40 plus 1 is 41 centimeters, right? So his bald spot's going to be 41 centimeters in 20 weeks, right? Another type of prediction, they want to know, will Mr. Camacho's bald spot ever be 40 centimeters in diameter? Okay, so remember, the diameter is an output, right? So this is T of n. So I'm going to go to my equation, right? So I have my T of n equals 2n plus 1, and this whole thing is going to get replaced with a 40. So I have 40 equals 2n plus 1. And then if it's ever going to be 40 centimeters, I need to figure out what n is. That'll tell me when that's going to happen here. Okay, so I'm going to subtract 1 from both sides. I get 39 equals 2n, and then we would divide by 2. Right, so the 2's cancel. We do 39 divided by 2. I'll grab my calculator for that. And I got 19.5. Now, I know that Mr. Camacho's bald spot will never be 40 centimeters in diameter because there is no term 19.5. We can only be term 19, but then we have to go to term 20. There's nothing in between. So Mr. Camacho's bald spot will never be 40 centimeters. It will magically skip over 40 centimeters and go directly to 41 centimeters. So the answer to this one is no. Okay, and this is why. If we get a decimal value out for that n value in a question like that, it's not going to exist. All right, guys, that's it for today's lesson. If you have any questions, make sure you ask myself or Mr. Rule in the Zoom chat. Have a great day, guys.